Hi guys. So this week we're going to be talking about graphing quadratics. So last week we were solving them. This week we're going to be graphing them. So first of all, there are three forms of quadratics that we're going to graph in different ways, and some of them are easier than others, and they give you different kinds of information. So we're going to be talking about three different forms of quadratic. The first one is the standard form, which is what this video is going to be about, which is the form that you would use if you're going to use, say, the quadratic formula. It's this form. The second form is called the vertex form, and that is, excuse my handwriting, sorry. That is the form that you would get if you completed the square. This is called vertex form. So this is called standard form. This is called vertex form. And then the last one would be factored form. What am I doing? That wouldn't. So I'm just using random letters. So this would be factored form, right? So if you factored it, you'd get this form. So factored form, vertex form, and standard form. And so we'll be talking about each of these in turn this week, but in this video, we're going to be focusing on standard form and what we can find from standard form and how we can graph that. So that is what is going on this week. All right, so let's go ahead and talk about standard form. So standard form, basically, like I said, it's the form you use for quadratic equation, right? It has to be in this order, and it's not factored, or there's no parentheses. It's just squared term, not squared term, constant term. Okay, so what can we see right away from this form? Well, first of all, let's talk about the Y-intercept. So remember that the Y-intercept is when x equals 0. So if I plugged 0 into this equation, I would get negative 0 squared minus 6 times 0 minus 3. So notice that this would just be 0 and this would just be 0, and all that's left would be the negative 3. That will always happen on quadratics. When x is 0, the first two terms are just going to be 0, and we're just left with the last term. So the y-intercept is always going to be this last term. So I can move one of these points on my graph, or I just know that I'm going to have a point on my graph. The y-intercept is going to be at negative 3. So that's the easiest point to find. Before we continue, I just forgot to say this. This shape, this is what the shape of a graph of a quadratic will always look like, and it's called a parabola. That's what this shape is called. So I'm going to be referring to it as a parabola a lot, so I'm going to make sure I talk about that. It's always going to be this shape. It could be facing up, it could be facing down, but it's always going to be this basic shape, which is called a parabola. So we have our parabola. We can tell by looking at the equation if it's going to be facing up or if it's going to be facing down. And we tell that by whether or not we have a negative in front here. So if there's a negative in front, it's going to face down like this. So we know that this parabola is actually going to be facing down because of the negative in front here. So we're going to have a maximum, and then it's going to be facing down. This maximum is called the vertex. So when there's a negative in front, it's a maximum. When there's no negative in front, it's a minimum. It's still called the vertex. The vertex is going to be a minimum if it's facing down, and it will be a maximum if it's facing, minimum if it's facing up, maximum if it's facing down. That's the vertex. So we found the y-intercept. It was at negative 3. I'm just going to put my dot there at negative 3. That's not the vertex. It's a different point. It could be the vertex. But I'm just going to put the point there right now. And we're going to need to find out what the vertex is. So the vertex we can find using this formula. X equals negative b over 2a. That will give us the x coordinate of the vertex. So this is the same ABC that we used for the quadratic formula. So in this case, a is -1 and b is -6. So if I plug that into this, I get x equals -6 over 2 times -1. So that's +6 over -2, which is -3. 6 divided by 2 is 3, and it's going to be negative. So my vertex is going to be at -3, but I don't know what the y is yet, so I need to figure that out. What is the y value? So I need to plug -3 into this equation to figure out what y is going to equal. So y is going to be -3 squared minus 6 times -3. I'm just plugging in -3 for x, minus 3. So I'm going to put that in a calculator. So I have -3 squared is +9. So I have -9, if that makes sense. So I have this is 9, minus 6 times -3. So -6 times -3 is +18. So right now I have -9 plus 18, because a negative times a negative is a positive, minus 3. And if I put that into my calculator, I'm going to get 6. I'm going to get 6. So the vertex, I'm just going to call it V, is at -3. That was the x that I found. And then I plugged that x into the equation to get y, and I got 6. I wrote 9, but I got 6. Sorry about that. Got 6. So the point of the vertex is going to be at -3, 6. -3, 6. So that is where my vertex is. And I'm just going to erase this so that we can see what's going on. And I'm going to erase these so that I have more room to write. All right. So I found my vertex is a -3, 6. So I can take I'll do it by hand first. So I go over to -3 and I go up to 6. And that is my point. That's my vertex. So how would I do this by hand? So here on Khan Academy is pretty simple, right? I can just take this and I put it on my vertex and I'm done. But what if I need to do this by hand? So what we're going to do there is I'm going to make an XY table. Make an XY table, and I'm going to need 2 numbers on either side of -3. So -3 is like my middle point. So I need -3, -2, -1, and -4 and -5. Those are the numbers that are going to go on my table. And 0, because I already know what it is. So I'm going to go ahead and just start with 0 and go to -5. I already have 0 graphed, so I wouldn't have to put it on my table, but just to remember that I do know that point, I'm gonna start there. So 0, -1, -2, -3, -4, -5. But in general, you just need 2 points on either side of your vertex. So remember, our vertex is here at -3. And put the 0 point. If it's one of those, great. If not, you can just, state it, or at least have it on your graph, because that's a point really easily, because it's just this last number. That's always going to be your y-intercept. So I have -3 here as my y-intercept. My vertex is -3, 6. So I've already found that. So I can just write that in. So let's plug in -2 because it's a small number. So let's plug in -2. So I have -2 squared minus 6 times -2 minus 3. So I'm just plugging in -2 for the x's, and don't forget your squared here. So I have negative, and then -2 squared is +4. So I have -4, and then I have -6 times -2 is +12. And then I have -3. So if I do all that, -4 plus 12 minus 3, I'm going to get 5. So here at -2, I have 5. But there's something I want you to notice. Parabolas are symmetrical. So if I'm the same distance away from the vertex, remember the vertex is here. I'm going to put a box around it so we remember that's our vertex. Think of this as the middle, right? So I'm 1 away from it here. I'm at 5. -4 is also 1 away. It's just 1 away in the other direction. So I could plug in -4 into this equation, but I would get 5 again because it's symmetrical. So let's look at it this way. If I plot this point, -2, 5, I'm going to go -2, and I'm going to go up to 5. That's that point that we found, -2, 5. And so -2, here's my middle. They're 1 away from each other. If I go 1 in the other direction, that's going to be at the same height. Since we already have this graph, we can see it. That's at the same height. So if I went 1 this way and it was 5, then if I go 1 this way, it should also be 5. So if you want to plug it in just to be sure, go ahead, but it's symmetrical. So if you're the same distance away, it should be the same number. So let's go ahead and plug in -1. So I have -1 times, nope. I have -1 squared minus 6 times -1 minus 3. So I have -1 squared is +1. So I have -1, -1 minus -6 times -1 is +6. Minus 3. So -1 plus 6 minus 3 is 2. So -1, we got 2. We plugged in -1. So goes 2, 5, 6. So then it's going to go back the same direction. So it's 2, 5, 6, 5, back to 2. And in fact, I even know that the next one, if I wanted to find -6, I know that that would be -3 because it's symmetrical. So it's going to go up and then back down the exact same way. So -3, 2, 5, 6, 5, 2, -3. If these are all 1 apart, then it will work. Okay, so I'm going to plot those points. So if I was doing this by hand, I didn't have Khan Academy doing the graphing for me, I would find my vertex using this formula, and then I got -3, plugged that in, and then got 6, and that tells me where my middle is. So that tells me which points I needed to choose. Because if I'd gotten a different number, like say I plugged these in and I got x equals 5, right? And my vertex was over here. Then the numbers on this table would be 3, 4, 5, 6, and 7. So this tells you what your middle number on your list is going to be. So I got -3. I plugged -3 in here and I got 6. So that told me where my vertex was. Then I wrote out which other ones I needed. So I need at least 2 numbers that are less than -3 and at least 2 numbers that are greater than -3. And then I'm going to plot all of these numbers. And this is my Y-intercept, which I always need, right? So that was this point here. So I'm going to plot all of these. So I have 0, -3. I have -1, 2 is right here. So -1, 2. -2 and 5. So -2, 5. -3, 6. -4 and 5. -5 and 2. And if we want to be thorough, -6, -3. And then I would connect them all with my lovely parabola here, and then put arrows at the bottom. So remember, this is what we would do if we were doing this by hand. So we would connect our dots with the parabola and put arrows at the end, and then we would be done. All right, so hopefully that helps. Let me know if you have any questions, and I will see you in the next video.